Hi everyone, welcome to Go Classes. In this lecture, we will study what is transitive dependency. In the last lecture, we have seen full dependency, partial dependency, and now we will see what is a transitive dependency. So the definition, okay, let's see what is the definition. So this is the definition of transitive dependency that is given in the textbook course. So let alpha beta be set of attributes such that alpha determines beta, beta does not determine alpha, and beta determines A, then alpha determines A is a transitive dependency. Okay, so basically this is the definition that is given in the original paper of code. In the last lecture also we have seen the definition of partial dependency, full dependency. Okay, and this is the definition of transitive dependency. Now let's see. So let's understand what is a transitive dependency. So transitive dependency. So what is a transitive dependency? The name itself is telling you that it is something or transitive. Okay. So you can notice what this says, that X determines A is a transitive dependency. Is a transitive dependency. So in short, we will call it TD. Okay. So X determines A is a transitive dependency if there, so x determines A is a transitive dependency if there exists y, such that y determines A. So basically if there exists a y such that y determines A, x determines y, and y does not determine x. Okay, so this is the only point. So we can say that this this x determines A, this is transitive dependency if there exists a y such that y determines A, x determines y. Now you can automatically see that this x determines A, this is a transitive dependency. Now you can automatically see that this is a transitive dependency. Okay, and also there is one more condition. The condition is that y should not determine x. So this is the transitive dependency. So remember, x determines y, x determines A. This is transitive dependency if there exists a y such that y determines A, x determines y, and y does not determine x. In this situation we will say that x determines A is a transitive dependency, or I can say that A is transitively dependent on x. Okay, so the definition is very simple. So remember, anytime you can notice, if you want to check if a dependency, let us assume, okay, how to check how to check if alpha determines beta is a transitive dependency or not. So how to check it, if this is transitive dependency or not? So very simple, alpha determines beta. If this is a transitive dependency, means they are transitively determining each other. If there exists a gamma, such that alpha determines gamma, gamma determines beta, but gamma does not determine alpha. Okay, so this condition must be there. In this situation. In this situation we will say that in this situation, if this happens, so if there exists a gamma, basically if there exists a gamma such that alpha determines gamma, gamma determines beta, and gamma does not determine alpha, in this situation we will say that alpha determines beta is a transitive dependency. Okay, or I can say that beta is transitively dependent on, beta is transitively dependent on alpha, dependent on alpha. Okay, so this is the definition. Let us take one example. So consider a relation R A B C D, and let's assume that you have this dependency you have. So let's assume AB determines CD, and let us assume C determines D. Now in this situation we can notice, okay, let's check whether this dependency is transitive dependency or not. Okay, let's check whether this is a transitive dependency or not. So this is what we need to check. So how to check whether this is transitive dependency or not? This C determines D. So it means that C determines D. This is a transitive dependency if there exists something, such that C will determine that will determine D, and that should not determine C. In this situation, we will say that, so there exists something, basically there exists a, I can say there exists a X. Okay, I can say there exists maybe Z. So you can notice in this situation, if this happens, if there exists a Z, such that this happens, then we will say that this is transitive dependency. But you can notice that there is no such Z. there is no such z. You cannot take any z here. Okay, whatever z you take here, okay, you can notice that this will never happen. So C does not determine D transitively. We can very easily see whatever z you take. Okay, here whatever z you take, you can never, because if you take for example z equal to AB, then this condition will not satisfy. So here I can say that this is not transitive dependency. So here I can say that this is not a transitive dependency. So this is not transitive dependency. This is not transitive dependency because there does not exist any z. So you can very easily see there does not exist any z. So I can say that C, okay, this is not a transitive dependency. Now let us take here, okay, let's see whether this is transitive dependency or not. AB determines D. AB determines D. Is this transitive dependency or not? Okay, let's check whether this is transitive dependency or not. So what we need to do, again the same concept. Basically we need to find whether this will transitively determine D. Can this AB transitively determine? So our question is, can AB transitively determine? Okay, transitively determine, can AB transitively determine D? So this is our question. Basically, okay, is do we have something here? Do we have something here such that this will happen, such that this diagram will happen? So this is the diagram of transitive dependency. This is the diagram of transitive dependency. Now let's see, is there something here such that this will happen? Yes, yes, because you can take here, I can say here you can take z equal to C. So this z equal to C will work. This z equal to C will work. You can notice AB can determine C. Okay, very simple. AB can determine C. C can determine D. And you can notice that C does not determine AB. C does not determine AB. So you can very easily see that. So I can say that this is transitive dependency. So AB determines D. This is a transitive dependency. Okay. So the concept is very simple. So okay, remember this is the diagram of transitive dependency. So I can say, remember the final point. This is the final point. Alpha beta, alpha determine if this situation happens. Okay, so I can say that if this situation happens means alpha determines beta, beta determines gamma, and beta does not determine gamma. Beta does not. Okay, so this is the diagram for transitive dependency. If this happens, then we will say then alpha determines gamma is a transitive dependency, or I can say that alpha transitively determines gamma, or I can say alpha transitively determines gamma, determines gamma, or I can say gamma is transitively dependent on alpha, or we can also say that gamma is transitively dependent on alpha, transitively dependent on alpha. So this is the definition of transitive dependency. I hope this concept is clear to everyone. Let's take one more example. Okay, so consider this example. Let's assume you have a relation R A B C D. Okay, and let's assume some functional dependencies are given to you. So AB can determine CD, and let's assume that C can determine D. C can determine D. So I think this example we have already seen. AB can determine. Okay, so this example we have already seen. So something else we can take. So let's take something else. So let's assume that you have this diagram and set of functional dependencies are AB determines CD, CD determines AB. Also, let's assume that so AB can determine CD, CD can determine AB, and also let's assume that C can determine D, C can determine D. Okay. So now you can notice here. So in this example, you can again you can very easily notice that AB determines D. Okay, that is AB determines D. If you notice this AB determines D, this is a transitive dependency because AB can determine C and C can determine D, and you can notice C cannot determine AB. Oh, sorry, here you can notice C actually can determine AB. C can determine AB. So this is not a transitive dependency. See here there is no transitive dependency. Remember, because C also determines AB. You can notice C also, because what is C plus? C plus is CD AB. So C can determine AB. So remember, this is not okay. So I can say, so here I can say you cannot take C. You cannot take C. you have to take something else. Okay, so you here actually I can say that this is not a transitive dependency. So here whatever you take, basically I can say that from this I can say that AB determines D is not transitive, is not transitive dependency. Okay, so this is the concept. The concept is very simple, and I hope this concept is clear to you. Now we will make some observations. So let's try to make some observations from this concept. So let's try to make some observations from this concept. So we have already seen that this is the okay, I can say that alpha, I can say, okay, if for example X determines A, this is transitive dependency. What it means, this is transitive dependency if and only if there exists something, there exists some Y such that X can determine Y, Y can determine A, and Y does not determine X. So in this situation we will say that this X determines A is a transitive dependency. Now from here actually we can make one observation that automatically, so this is the definition of transitive dependency, but automatically what will happen is that A cannot determine X. So here automatically this will happen. Some, I can say, some results we can get, some conclusion, or I can say some observations we can get here. So some observations, what we can get. So first you can notice that here A cannot determine X. So A does not determine X. Why? We can prove that A cannot determine X here. A cannot determine X. You try to prove it. Can you prove it? A cannot determine X. This we can prove it. Okay, so let's prove. So basically remember, A cannot determine X. A cannot determine X. And how can we prove it? The proof is very simple. Let us assume A determines F. Okay, prove by contradiction. So assume A determines X. Now what will happen? If A determines X, then what will happen? Now you can get a contradiction. So for contradiction, we are assuming okay, this is a proof by contradiction. So for contradiction, we are assuming that, let us assume that A determines X. If A determines X, then what will happen? Notice that Y can determine A. We already know Y can determine A. Okay, so Y can determine A, and we are assuming that A can determine X. So Y can determine A can determine X. It automatically means that Y can determine X. So it automatically means Y can determine X, and this is the contradiction because Y does not determine X. So this is the contradiction. So I can say this is the contradiction. This is the contradiction we got. So you can notice that A cannot determine X. So automatically, actually, from this automatically we can imply that A cannot determine X automatically. Okay. Similarly, you can also make another observation is that, so A cannot determine X. Okay. So this is the point. And remember, A can determine Y. There is no problem with that. A can determine Y. There is no problem with that. For example, this is the next point. This is the next observation. Second, A may or may not determine. A may or may not determine Y. May not determine Y. Basically, here there is no problem. Determine Y. Because you can notice, let's take example. So in this example you can notice A, B, C. Let's assume you have let's assume we have A, B, C, D. So this example we have already taken actually. So here you can notice if your set of FDs, your set of FDs is AB determines C and C determines D. So this is the set of FDs. Now here you can notice that AB determines, here we can notice AB determines C, C determines D, and C cannot determine AB. So we can say that this is transitive dependency. This example we have already seen. And you can notice here that D cannot determine C. D cannot determine C. So here you can notice that AB determines D. This is transitive dependency. This is transitive dependency. And you can also notice that here D does not determine C. So this does not determine this. Okay. So you can notice, but we can take another example where it will happen. So for example, just consider this example. AB determines C, C determines D, D determines C. Okay. So consider this set of FDs. Now you can notice again here. Now you can notice AB determines C, C determines D. So here C cannot determine AB, C cannot determine AB. So this is the definition of transitive dependency. So we can say AB determines C is a transitive dependency. But you can notice that here D is determining C. So here you can notice D is determining C. So the point is very simple that uh, here in this diagram, in this transitive dependency, if you have a transitive dependency like this, then A cannot determine X. Okay, so you don't have to write it, it will automatically imply. So this is some observation or some implications. These are implications from the definitions of transitive. Some these are implications from above definition. From above definition. So these are automatic implications from the above definition that this A cannot determine X. You don't have to write it. This will automatically happen. And you can notice A may or may not determine A may or may not determine Y. A may or may not determine Y. So this is the final point. So let me just summarize this. Let me summarize this definition of transitive dependency. So remember, this is the definition of transitive dependency. So you have X. Okay, X determines Y determines A, Y does not determine A. So this is the definition of transitive dependency. So in this situation, you will say that this X determines A, this is transitive dependency, means X is transitively determining A. Okay, so this is the definition of transitive dependency. And remember, automatically this will happen. Here automatically this will happen that A cannot determine. Okay, so here you can notice, so A cannot determine X. So here A cannot determine X. This will automatically happen. We don't have to write it. This will automatically happen. And also this will also happen that, of course, this will transitively happen. This will transitively happen. And you can notice that this may or may not happen. This may or may not happen. So I can say that this may or may not happen. So either this can happen. So this A can determine Y. This may or may not happen. So question mark means this may or may not happen. So this is a question mark. Okay, so this is the complete some observation. This is the complete thing. But anyway, this is the definition of transitive dependency. I hope this concept is clear to you and you can see the definition. So many students have doubt in the definition of transitive dependency. So you can see the definition from Cork and you can also see the definition from the original paper of code. So this is the definition. Okay, I hope this concept is clear. So now we have seen what is a transitive dependency, what is a partial dependency, what is a full dependency. And okay, so all these concepts we have seen. Now we will see 2NF, 3NF. Okay, thank you everyone.